Operations with polynomials. Okay, so this one wasn't, I hope, not too bad because you already had all the skills you needed here. You just needed to apply them in a little different way than you have in the past. And what do I mean by that? Well, let's start with the first one, adding, right? I'm adding this yellow one to this pink one. Okay, well, what am I doing? Combining like terms. We've been combining like terms for a long time, right? Since Algebra 1. What do? Well, I have 3x to the third, and I have x to the third. How many x's to the third is that? That's 4x to the thirds, right? I got 2x squared, and I got minus 10x squared. Well, that's negative 8x squared, right? Negative 7 and 8 is 1. This one is by itself, so it just stays by itself, right? That's as basic as this is going to get, right, when you're adding them together, okay? Some people like to stack, which is basically take one of them, write it out, and take the other one and stack it underneath with the like terms lined up, get you the same result, okay? Students have different preferences there. Question?
What if you lined up like two numbers and it had two different exponents? Like, would you add
You wouldn't do that. So when you stack it, you have to be careful to only put like exponents underneath each other.
Would there be an equation where like there's one with like different exponents?
Yes, for example, this one, right? I wrote 3x to the third, 2x squared, minus x, minus 7. And then I started to write the next one, and I wrote x to the third, minus 10x squared. And then I saw, oh, I don't have an x in this one. So I left it blank, and I skipped it. And I put 8 under the negative 7. You see how I skipped this spot? And that makes sure that you don't add unlike terms. You just stack them together. Okay? That's why people like this. It keeps you from combining the wrong things. Okay? All right, now the only difference with subtracting is we know if you subtract a parentheses, what's true? That negative goes through all of them, right? Through the whole parentheses, right? Meaning it flips all the signs. So the first step for these, when you're subtracting, write the first one as it is, and then write the second one with all of, and I'm not going to underline because that'll be confusing. Write the first one as it is, and then the second one rewrite with all the signs flipped. Negative, negative, positive, negative. Now it's just like the last problem, right? Once you flip those signs, it becomes just like the adding one. You're combining like terms, you could stack it, you could do it this way, whichever way works for you, okay? You just got to remember to flip those signs of the second one first, okay? Multiplying, again, there's some review here. Now this part's a little new, but essentially what you need to recognize, excuse me, is you have 2 terms in this one, and you have 3 in this one, okay? So if you're doing a box method, you're going to have 2 boxes by 3 boxes. You set it up 2 by 3, put this one on the side, put this one on the top, and then do each box one at a time. That times that, that times that, that times that, that times that, right? What you're going to find is you get these like terms in your diagonals. This one and this one will stay at the end and the beginning, and the other stuff you combine, and you get those, okay? Now, there is another way that some students prefer if you don't find it confusing, right? But to do this way, you have to really understand what's happening here. If I'm multiplying this by this, right, I'm multiplying everything in here by everything in here, right? Meaning I'm multiplying x times everything in here, and I'm multiplying negative 3 times everything in here. And that's what this is. X times everything in there, minus 3 times everything in there, okay? Then you just do the math here, bring it all together, and you get the same answer. But if that's confusing, just use that box method, and you'll be okay. Okay? All right, so there's a reason why this lesson had adding, subtracting, multiplying, and it stopped. Because dividing is its own beast, right? Dividing's new. How do you divide polynomials, right? How do you divide a big equation by another equation? And that's the next lesson. So do we have any questions on this one? Wait, let me make sure I finished here. Oh, one last thing here. If you have something like this, right? First thing you got to recognize is that you can expand that because it's 2 to the second. So it becomes x plus 4 times x plus 4. But then you get this situation where it's this times this times this. And some students freeze at this point because they're like, what do I do? Okay? Well, let me ask you a question. If I gave you 2 times 3 times 4, would you go 2 times 3 times 4? To multiply 2 times 3 times 4, do you just do it all at once? 2 times 3 times 4? No. No, what do?
You do 2 times 3.
You do 2 times 3.
And then 6.
It's 6. And then 6 times 4 is 24.
Yeah.
Yeah. Same thing. If I have 3 things being multiplied, I can't do that all at once. I do this times this. Bring it over to the side. Do it. Oh, I found out that this times this is this. Put that in its place. Now I can do this times the last piece in the way that I just talked about with multiplying, and I'm good. Right? You can't do it all at once. If you got 3, just do the first 2, then bring in the last one. Does that make sense? Okay. All right. Any other questions here before we move on to long division? Okay.